So far in our discussion, we've been treating light as a wave, but we haven't actually talked about why it is a wave or what evidence there is to show that it is a wave. Historically, light was actually, and by Newton, it was actually thought to be a collection of particles of different colors. And Newton himself, this is Newton's theory, and he called these little particles corpuscles. Corpuscles. And he thought that they sort of moved with a force, and like particles, they would just move sort of in an array. So in sort of in straight lines, if one were to move things. But what was really interesting is that there was a very famous experiment done to test this, to test whether light was a particle or something else. So this is known as Young's double slit experiment. And what it is there is like a screen right here, and there are two grooves, like two gratings as they call it. And this sort of orangish color, this is basically, light, like white light, that's sort of sunlight that's shown onto the screen. So if light was a particle, and over here A, this is just a screen, so it's just like the back of a projector or something. So if light were a particle and it moves in straight lines, what we would expect are simply, two lines. Right? Two lines like that, and the rest of it is being blocked because it doesn't go through, the grooves. However, what we do, if you in thorough experimentation, we actually don't see two lines. What we see instead is a number of lines, and the way it works out is like this. The middle line is sort of the most intense, and then from then on, we see things like that, and then we see lines like that. So we actually see a whole spectrum of lines. This is actually what we see. This is what we expect, but we don't see that. And this is actually what led to us to the idea of treating light as a wave. So in our next video, we will explain why we see like a number of lines, a whole spectrum of lines, as opposed to just two lines.